morning, everybody. Oops, good morning, everybody. So we're going to start off and we're going to define some terms. And so the first thing we're going to talk about is population and sample. The population is the entire collection of individuals that you want to study. A sample is a subset of the individuals, and it's important to have some sort of randomness. So I say here random important. All right, well, let's first define random. And I have the definition here. Each individual in the population has an equal chance of being selected for the sample. Okay. The reason that we want everybody to have an equal chance is we're trying to avoid generating bias. Now, there are times when we give some group more weight. And I'm just going to take a simple experiment, and we're going to say we're going to roll the numbered cube, or a die, whatever you want to call it. And we have we have four categories. We have even numbers, and then we have the 1, the 3, or the 5. Well, the even numbers, because there's more of them, and I say more of them, see, each of these are individuals. So we're going to see as the probability of a 1, well, that's 1 out of 6. The probability of a 3, that's 1 out of 6. The probability of a 5, well, that's also 1 out of 6. They're all weighted 1 out of 6 because they're each individuals. But if we group together the even numbers, we now have 3. And so the weight is heavier there. There's 3 out of 6. So the probability here would be 3 out of 6. Okay? And so we give more weight if it's warranted. We try not to give more weight because unless we have to, because we try to avoid a thing called bias. And bias is when we give more weight to one group or another group when they don't actually deserve it. Okay, now I have this second piece here called a simple random sample. Well, a simple random sample is the first of our experiments. And a simple random sample, by definition, says every group of size n has an equal chance of being selected. All right, so this size n, it actually has to be selected prior to the beginning of the study. So let's pretend our population are the numbers 1, 2, 3, and 4. We have thing 1, thing 2, thing 3, and thing 4. Okay. Now, we've done some calculations and we figured out that our n, our sample size, needs to be 2. Okay, so what we do is we create all of the sample sizes of size 2. Now, I do need to point out that when we get to a thing called the central limit theorem, and we're talking about simple random sample, and I don't make a big deal out of this, and at this point in time, there isn't anybody that's going to make a big deal out of it, but we assume that we have width replacement. So if I draw a 1 out, I can draw another 1 out. So one of my sample sizes of size 2 is 1, 1. Another one is 2, 2. Another one is 3, 3. And another one is 4, 4. Okay, so all the possible samples of size 2 are listed here. I have 1, 1, 1, 2, 1, 3, 1, 4, 2, 1, 2, 2, 2, 3, and so forth. And what happens is each of these samples are thrown into a hat. They're shuffled around. And now every sample of size 2 has an equal chance of being selected. Okay, I hope that makes sense.